This is Mr. Hassan's Maths channel, and I am now answering question number 7 from the May-June 2023 paper 1 variant 2 from the Cambridge 9709 International A-level paper. And here we have a question about trig identities, I guess. It says, by first expanding cosine theta plus sine theta all squared, find the three solutions of the equation cosine theta plus sine theta squared equals 1. So they're asking us to solve this by first expanding this expression. So when you expand a square bracket, we just basically can use the pattern of squaring square brackets, which is quite simple. You square the first term. So cosine theta all squared, which is written as cosine squared theta. Then you multiply these two terms together and then multiply that by 2. So you'll end up with 2 times cosine theta times sine theta, and then you square the last term, that's sine theta all squared, which is sine squared theta, and equals 1. So we have to solve this equation. Now, one of the things that we know from our identities is that cosine squared theta plus sine squared theta equals 1. And what we have here, if I write these together, you have 2 cosine theta, you have 2 cosine theta times sine theta plus sine squared theta plus cosine squared theta equals 1. Now this basically is going to be 1, right? Sine squared theta plus cosine squared theta equals 1. So I can write this as 2 cosine theta times sine theta plus 1 equals 1. Now if I subtract 1 from both sides, I end up with 2 cosine theta times sine theta equals 0, which means that cosine theta times sine theta equals 0. How do I solve this equation? Well, we can use the zero product property. When I know two things multiply together to give me 0, then one of them must be 0 or the other one must be 0. So I can say either it's cosine theta that equals 0 or it's sine theta that equals 0. And we want to solve this in the range between 0 and pi. Okay, so this is between 0 and pi, including 0 and including pi. So we know that the cosine curve hits 0 at pi over 2. Okay, this is 0, this is pi over 2, this is pi. And the sine curve hits 0 at 0 and at pi. Okay, between 0 and pi. So this will be, the answer would be pi over 2 for this part. And for this part, theta would be 0 and pi. Okay, so the three solutions, as they asked us to find, are going to be theta equals 0, pi over 2, and pi in radians form. And there's the answer to 7a part 1. And then it says 7a part 2, hence verify that the only solutions of the equations cosine theta plus sine theta equals 1 between 0 and pi are 0 and a half pi. So it says hence. Okay, it means using our results that we found over here. Okay, so we want to show that the only solutions for cosine theta plus sine theta equals 1 between 0 and pi are 0 and pi over 2. Okay, so in order to do that, we can take our answers here. Okay, and we can say that when we put theta as 0 inside here, we're going to get cosine of 0 plus sine of 0, and that's equal to, if you put cosine of 0, you're going to get 1. Sine of 0 is going to be 0. That's going to give you 1. So that's one solution for this equation. It makes it true. Okay. And when we put theta equals a half pi, we'll have cosine of a half pi plus sine of a half pi is going to be, the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So you end up with 1. So those are the only two solutions. If we try to use theta equals pi, okay, we will end up with cosine of pi plus sine of pi, and you'll end up with minus 1 plus 0, which is minus 1, which is not a solution to this equation. Okay? It's because it's going to be, you add them, you're going to get minus 1, not plus 1. Okay? Plus 1 is when you got this angle here, 0, and pi over 2. The value of sine theta plus cosine theta will be 1 here. The value of sine theta plus cosine theta will be 1 here. But the value of sine theta plus cosine theta here will be minus 1. Okay, so that's why pi won't give us the correct answer. So I guess that's what they intend you to do, substitute the values in, and so you can say, therefore, theta equals 0 and theta equals pi over 2 are the only solutions in that range. The only solutions between theta is between pi and 0. Okay, that's part 2 done. Now for part 3, it says prove the identity sine theta over cosine theta plus sine theta plus 1 minus cosine theta over cosine theta minus sine theta gives you this expression cosine theta plus sine theta minus 1 over 1 minus 2 sine squared theta. So to prove this, what I'm going to do is I'm going to combine these two into one fraction because we're going from two separate fractions to one single fraction. So I'm going to combine these together. I'll multiply the denominators together, okay, which will give me cosine theta plus sine theta. I'll write the steps out in full, but you can think of this as a difference of squares. But cosine theta plus sine theta times cosine theta minus sine theta. And on the numerator, you're going to multiply these together. So you have sine theta times cosine theta minus sine theta plus, and then these two multiply together, you'll have 1 minus cosine theta times cosine theta plus sine theta. So you have to be very neat in these questions. Now that is going to give us, if I expand this, I'm going to have sine theta times cosine theta minus sine squared theta. Then I'll have plus, when I expand this, I'll have 1 times cosine theta, which is cosine theta, and 1 times sine theta, which is plus sine theta. Then sine theta, sorry. Then minus cosine theta times cosine theta is minus cosine squared theta. And minus cosine theta times sine theta is minus sine theta cosine theta. And that's over. Now, if I expand the denominator, it's like a difference of squares, which will give me cosine squared theta minus sine squared theta. All right, so now we can see a few things are going to happen here. You have sine theta times cosine theta minus sine theta times cosine theta. They will cancel out. And you've got cosine theta plus sine theta. And you've got these two together. I'll write them together. Minus sine squared theta minus cosine squared theta over. Now, we want the denominator to become 1 minus 2 sine squared theta. So what I'm going to do is I'm going to take the cosine squared theta here and replace it by 1 minus sine squared theta, because we know that sine squared theta plus cosine squared theta equals 1. So that means I can replace cosine squared theta with 1 minus sine squared theta, and I've got another minus sine squared theta there, and we can see that's going to give us what we need in the denominator. So this denominator is going to be sorted out. And the numerator, I've got cosine theta, I've got sine theta, but I've got minus sine squared theta minus cosine squared theta, and I can do something about this as well, and it will give me exactly what we've got there. Okay, so what I'm going to do now is I'm going to write this as cosine theta plus sine theta. I'm going to take out minus 1 as common in these two. That will give me sine squared theta plus cosine squared theta in the bracket, divided by, and this is 1 minus 2 sine squared theta. Now this gives me 1. We know sine squared theta plus cosine squared theta equals 1. So we finally end up with what we have to prove, that cosine theta plus sine theta minus 1 over 1 minus 2 sine squared theta. That's exactly what we had to show. Okay, so that's done, part B. And then part C, it says, using the results of A part 2 and B, solve this equation. So That's B part, that's A part 2, and that's B. That's what we got from those two. Okay, and from here we found that the solutions were basically between 0 and pi, the solutions were 0 and pi. Pi over 2 wasn't a solution. No, 0 and pi over 2 were the solution, sorry. Oops, what happened there? So here theta was 0 and pi over 2. Okay, so now we want to use the results of A part 2 and B to solve this equation. So if I look at what we have here, okay, I can see that we have sine theta over cosine theta plus sine theta plus 1 minus cosine theta over cosine theta minus sine theta equals this. And that same thing is equal to that. So these two must be the same. Okay, so what I can do is I can say 2 times cosine theta minus sine theta, okay, which is minus 1, which is in brackets, that part, must be the same as what we have here, which is cosine theta plus sine theta minus 1 over 1 minus 2 sine squared theta. So I'm going to keep this as it is because I can see that there's a kind of similarity between this expression and that expression. Well, I'm going to just get rid of the fraction. So I'll multiply both sides by 1 minus 2 sine squared theta. So I'll have that times 2 cosine theta minus sine theta minus 1. So I've just multiplied these three things, like this bracket with those two, without expanding it. And then this is equal to cosine theta plus sine theta minus 1. Now, what I'm going to do is I'm going to take this like as a whole thing and move it on this side. So I'm going to take it like this. I won't change the signs of what's inside it, but what I'll do is, so that it looks the same as that, because I want to try to make this simpler, not more difficult. I'll have 2 times 1 minus 2 sine squared theta times cosine theta minus sine theta minus 1. And I'll put minus, in brackets, cosine theta plus sine theta minus 1 equals 0. This is the same as, taking them on the side individually, and you'd end up with minus cosine theta minus sine theta plus 1. It's the same thing, but I've kept it in this bracket. Why? Because I noticed that these two are going to be the same, and when I want to solve equations like this, I want to try to factorize, use the zero product property. So what I'm going to do now is I'm going to take as a common factor this cosine theta minus sine theta minus 1. And on this side, I'm going to have 2 times 1 minus 2 sine squared theta, and I have minus 1. Why? Because this times this will give me exactly that, and this times minus 1 is going to give me that. And that's equal to 0. Now I can use the zero product property. I can say, that's supposed to be a plus there, by the way. I can say cosine theta plus sine theta minus 1 equals 0. Or I can say 2 times 1 minus 2 sine squared theta minus 1 equals 0. So I have these two equations. This will lead me to the equation cosine theta plus sine theta equals 1, which between our range that we want to solve, okay, we know already the solutions theta equals 0 and pi over 2. Okay, so those solutions are done. And for this one, we can rearrange this. We can say 1 minus 2 sine squared theta times 2 equals 1. Divide by both sides by 2. We have 1 minus 2 sine squared theta equals 1 over 2. We can subtract half from both sides and add 2 sine squared theta to both sides. We'll end up with 1 over 2 equals 2 sine squared theta. And now, I think I've run out of space. Okay, I'll just fit it over here. And now I can solve this. Well, I can say, I'll just continue over here. I can say here now that 2 sine squared theta is equal to, or sine squared theta is equal to a quarter. Dividing both sides by 2, that means sine theta is equal to plus or minus a half. In which case theta is equal to inverse sine of a half gives me 30 degrees, which is pi over 6. And 1 pi minus pi over 6 gives me 5 pi over 6. Okay, so those are between 0 and pi, two solutions. Then we also have where the sign is negative. Well, that happens to be only in these two quadrants. Inverse sine of negative a half will give me negative 30 degrees, and it will give me, that's going to be minus pi over 6. And it will also give me 7 pi over 6. Because it's going to give me an angle over there, these two quadrants. It's not going to be when theta is between 0 and 180. So the negative part won't give me an answer. Okay, sine, this is for sine theta equals a half. These two answers for sine theta equals negative a half. No solutions in our range. Okay, because you're going to get minus pi over 6, which is outside our range. And the other angle we'll form will be pi minus pi over 6, which is going to be 7 pi over 6, which is also outside our range more than 2 pi. So we end up with 0, pi over 2, pi over 6, and 5 pi over 6 as our 4 solutions. Okay, so there we have our answer to this part of the question, which is part C, which concludes our question here. Now, don't get bogged down by all this algebraic manipulation here. I don't think they gave us enough space, really, to be honest, for this part of the question, but it's quite doable if you just try and keep in your mind that these are the same thing. Okay, and try to think about factorizing. This is the same as that. That's why I tried to keep them the same. I took that as a common factor, and it made life a lot easier than expanding all of those and having all these long terms, which will take you ages to sort out. All right, so that's the answer to question number, I think it's number 9, part C. Oh, it's number 7, actually, sorry. Number 7, A, B, and C done. It's all about trig identities and solving trig equations. It's a bit tricky. A lot of, algebraic type of manipulation, but hopefully you understood. Other questions from this paper can be found in the playlist that will appear in this section over here. Other questions from the topic of trig identities and equations from P1 of of Cambridge over here. From P2 of Edexcel, you'll find lots of questions dealing with trig identities and equations, which are very similar to these questions. So it's useful for you to watch videos for there to practice. And also, you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.